Welcome to Rges Algebra 1. This is lesson 18B, and we'll be discussing section 7.8, which is called Solving Systems of Equations by Substitution. Now recall the last lesson you had before was where we had two equations for lines, and we graphed one. Let's see, So we're talking about systems of equations, and systems of equations simply means that we're dealing with more than one equation, and we want to find out what values of x and y, or x and y and z, these things can go on and on, which values will make each statement true. So right now we're going to deal with two equations. The variables x and y are going to be found in both equations. And remember, of course, that x and y can also be identified as a point. Another word for that is an ordered pair, where the one variable is always first and the other variable is always second, always in the same order for every pair of numbers. Okay. Now, in this graph, which you did this last lesson, you were identifying a solution to a system of equations. These two lines would have only one solution, and that is that point right there. And you would answer it with an ordered pair. Why? Because that is the only point that lies both on the red line, line 1, and the blue line, line 2. Now, of course, we don't want to graph with graph paper all our lives, and that's not the most accurate way, as you noticed, to read off a value and make sure that you've got it accurately, especially if it's not designed to come out with nice whole numbers. So we want to discover some other ways to solve systems of equations. Solve a system of equations. Let me write that down again. And recall that the solution is an ordered pair, just like that. Okay. We don't want to do it by graphing. We want to do it in another couple ways. So in the next two lessons, we're going to learn two other techniques for solving a system of equations. The first technique will be this lesson, and it will be called by substitution. Now, you already know what substitution means. Recall when we had an equation like, well, certainly you did it for evaluating an expression. If I said 3x plus 2, and I wanted you to simplify that expression, you could only do so if I gave you a value for x. If x equals -1, let's say, then I would take this value, plug it in for x, substitute it, and then simplify. Now we're going to take that same concept, but we're going to have equations, linear equations, equations that have two variables, and because they represent lines and not just points, it will look like something like this. Let's say I have 3x plus 2y equals 9, and a second equation, so that's my one equation, it's a linear equation, and I'll have a second equation that says y equals 2x. Now, to substitute, everywhere I see a y in the first equation, I will plug in this new value. If y equals 2x, every time I see a y, I can plug in or substitute 2x. So I'm going to do that into the first equation from the second equation, taking the information from the second equation, right? So I'll say 3x plus 2y, y equals 2x, equals 9. And now you can see that I have an equation that only has x's in it. Well, you can solve that. You've always been able to solve that for quite some time now. Okay, so we'll say 3x plus 4x equals 9, 7x equals 9, and x equals 9/7. So now remember my solution is an ordered pair. So my x value is 9/7, and now I have to find my y value. The easiest way in this example to find the y value is to plug into the equation that says y equals. Well, y equals 2 times the x. If x is if x is 9/7, then the y is 2 times that, or 18/7. And this is my solution. So we have taken two equations, a system of equations, which would always be indicated that I want you to consider these two together, okay, and find the solution that works for both of them. Okay. And I have substituted from the second equation into the first equation for one of the variables, and then I have solved the first equation for the x, and then the second equation I've used to solve the y. So that's the method. So let me illustrate this by several other examples. Here is a second system of equations on the right here. Now, I'm going to pick whichever equation. I have two equations, equation 1 and equation 2. I'm going to pick whichever one's going to be easiest to solve for one variable. And I would say if it has no number before it, no numerical coefficient, it will be the easiest to solve. So this second equation will be the easiest to solve, and it would be easiest to solve for the y. So can we do that in our heads? Well, if I would take the y to the right to make it positive, and I would take the 4 to the left. So I would end up getting y equals 3x minus 4. Is that clear to you? Pause it. Make sure it is. Okay, you could do it in a couple steps, or you can learn to do it in one step. And now what do? I'm going to take this value and plug it into the other equation, which in this case is the first equation, every time I see a y. Just like that, and then I'm going to solve. I'll distribute, I'll gather like terms, and I'll solve for x. Now what I have is the first half of the solution. Remember, the solution is an ordered pair. My x value is 10/17, and now I need the y value. How would I get the y value? I would go up to my second equation after I manipulated it so that it's y equal, and I'll plug in for the x and get y. Now once I have solved for y, go ahead